So here we have an example where logarithms are used in chemistry. It says, recall that in chemistry, pH equals the opposite of the logarithm of H plus, and H plus represents the concentration of hydrogen ions. Okay, so now they say if the concentration of hydrogen ions in the liquid is doubled, what's the effect on the pH? Well, first consider, let's just say you have a concentration of C, that's your H plus. And then we'll double it. Okay, so the pH of just C is going to be equal to the opposite of the log of C. Okay, so that's like originally. Now I don't want to use pH, so let's just say original. They use P in the book. So that's the original pH. And we're going to represent it as P. So that's just if you have a concentration of C, that's what it would look like. Now we're going to go to a situation where now we're going to double it. So now we have 2C. So the pH is going to equal the opposite of log 2C. But that we know we can split that up into two separate logarithms. By the way, these are all common logs, so that's great. Now, if you distribute that subtraction or that opposite sign, you get this. This part, that is what you had originally. So that's like if just the concentration was C, you would get some amount of pH, okay? P, call it P. This right here, that's the effect then on the pH. And that is a number. So we can put that in our calculator, which we're going to do. We're going to say, what is the log? Or let's do the opposite. What's the opposite of the log? It's a common log, 2. We can just use our log button. And let's see, let me scroll. The opposite of log 2 is approximately negative 0.301. So the effect is it's going to decrease the pH by about 0.301. Okay, that was the effect then. It's going to lower the pH and it's going to lower it by about 0.301.